Hello, everyone, and welcome back to another exciting episode of the SOPE Weekly Podcast. My name is Chris Miller, and today I got a special guest with us, Mr. Tony Long. So let's please welcome him to the show. And Tony, thanks for joining me here this afternoon.
Yeah, glad to be here with you.
All right.
Thanks for having me on.
Oh, my pleasure. So if you would just kind of give a short introduction and tell the audience who you are.
Sure. Again, my name's Tony Long. I'm a licensed PE in the state of Texas, petroleum engineer by degree and trade. Actually came from Ohio, was born and raised just outside of Marietta, Ohio, spent most of my life between there and northern West Virginia. And then in late 2016, moved to Texas for a different job opportunity down here. And actually went through with my licensing procedure while I was down here in Texas. Currently work as a production engineer for upstream exploration and production oil and gas company.
Sounds exciting. So a Buckeye moving to the Longhorn country.
That's correct. I'm on the Buckeye side. My wife went to WVU, so we've got some unfriendly flags flying down here amongst all the Texans. So
I'm sure that's going well. So I appreciate you coming out again. So, we have an interesting topic, and one about is, I guess, the main topic for today is the reduction of flared natural gas as well as methane emission in the state of Texas. I'm from California, so I know a lot about as far as trying to reduce emissions because it does some nasty stuff to the air.
Mhm.
I grew up by Santa Barbara, where blue skies, not too far from the ocean, and then I moved down to Southern California, and before I moved, everyone's like, "Oh man, you're going to move down to Southern California. You're going to be able to taste this air." I'm like, "What are you talking about?" I said, "The air doesn't have a taste to it." Sure enough, man, I moved from blue skies to brown skies, and I was like, "Is it fog?" They're like, "Nope, that's what they call smog." So, yeah. So today's topic, I was like, "Oh, this will be interesting." Talk about it coming from the state of Texas. I did see something that is interesting. I don't think I've never heard of it. Is the reduction of flared natural gas. So what in the heck is flaring, and why are they doing it?
Yeah. So flaring is essentially any natural gas that you get that's associated with the extraction of oil, and it's anything that's burned. So it can be it's essentially like a pilot light on your stove, or on your water heater. Any of the gas that you don't have a home for, it ends up getting burned. In a nutshell, that's what flaring is. Happy to go into more detail, and I'm sure we will here over the
Yeah,
next.
I mean, it caught my eye, so I started Googling it. I'm like, okay, well, yeah, I'm reading it, but I'm still not getting the idea of it. But yeah, we'll get into a little bit more detail. So, what is the difference between lit and unlit flares?
Yeah. So unlit flares are by and large a thing of the past. If a flare is unlit, that means it's ineffective.
Hmm.
So a lit flare is going to be, again, to use the water heater analogy, there's going to be a constant stream of gas, a very low volume of gas with a flame so that it's always lit. And anytime the facility or a well has a need to flare a larger volume of gas, you already have a flame there. So when the gas gets sent to it, all the gas is combusted, and you don't have gas that's just venting unrestricted to the environment. So in modern times, really the unlit flares is an obsolete thing. 10 years ago, you probably would have seen a lot more of it. I wouldn't doubt if there isn't some small mom and pop operations out there where they have a well on the back 40 of the farm and there's still an unlit flare. But by and large, all the larger prudent operators are going strictly to lit flares.
I mean, so I guess I don't know if there's an obsolete question on it, but is one option better than the other?
Yeah. The lit flare is by far the best. Typically, we look at about a 95% efficiency for hydrocarbon destruction with a lit flare. If a flare is unlit, then there's a high percentage chance that you're going to be releasing methane and all the other associated compounds with it to the atmosphere without them being combusted. Methane it's a greenhouse gas. It's a very strong greenhouse gas. So when it's released to the atmosphere in its pure form, it can have fairly significant effects for the whole global warming, greenhouse gas effect that we hear so much about these days in
Wow,
the
that's
news.
interesting. So I'm going to take a shot at this, and I'm sure I'm going to need your help, maybe correcting and getting me back on track, or I could be completely off base. So
Sure.
when I looked up flaring, and it was talking about I don't know, is it done to, I guess it's better to vent that, I guess, a smaller proportion than a larger, or am I way off again? So I guess the question is, what is venting and why do we do it?
Again, venting is one of those things that the industry is trying to move away from. As most people are probably aware, the impact on the environment has, that dynamic has changed drastically over the last decade. 10 years ago, it was being talked about. Not a lot was being done. Fast forward to today, and it's one of the leading topics within our company, within a lot of the other upstream oil and gas operator companies. So again, the venting, the disadvantage there is you're just releasing those compounds without them being combusted, and they have a very strong greenhouse gas effect. As you can imagine, I mean, venting there's not really anything that's required
Mm-hmm.
to physically do the venting. So years and years ago, people probably did that because it cost them nothing to do, is where controlling these emissions, reducing flaring, there's a lot of process and engineering controls that have to get implemented. And with that, you're buying equipment, you're utilizing expertise, it costs money. But fortunately, I mean, I'm proud to say the industry has definitely moved in that direction. So venting is, again, that's another one of those things that everybody tries not to do that. To the greatest extent possible, that's eliminated at all aspects of the game for us currently.
Ah, very nice, very nice. So we talked, so flaring is an environmental concern, right?
Yep.
And why so? Is it because it's
Well,
releasing it uncombusted?
yeah, flaring is a source of greenhouse gas emissions. I've utilized some public data here to give you some of these numbers in case people want to look into themselves. The World Bank is involved heavily in the whole flare reduction initiative worldwide that's going on. And according to them, each cubic meter of flared gas results in roughly 2.5 kilograms of CO2 equivalent emissions.
Wow.
So to normalize it, a lot of people, they use the term CO2 equivalent because carbon dioxide is so prevalent. So even though you flare it, you are getting some CO2 equivalent emissions out of it. And then, as I mentioned, you have a 98% efficiency with a flare. So that means about 2% of that gas that goes through the flare is not being destructed, and therefore that methane is going into the atmosphere in its pure form. And methane itself, again, according to the World Bank, it has up to 80 times the greenhouse gas warming effect of CO2. So that's the reason why methane in particular is a big concern on the environmental side for both flaring and emissions in general.
Holy cow, that's some useful information. So thank you for that. So, I mean, is there I guess, a safe way that someone can do flaring or flare safely? I guess, better way to say it.
Yeah, for people that haven't been on an oil and gas pad or a facility, essentially we have a small, we'll just call it a chemical plant. In Ohio, there's a lot of chemical plants up and down the river. The difference is those are stationary, so they set everything up. They have to build it one time, and they can keep fine tuning that same one. We build pad after pad, month after month, and so essentially we're setting up small process facilities at each one of these well sites. So there's a few considerations when you're trying to do this safely. First of all, you're going to utilize modern technology with your flare. It's not just as simple as having a pipe with a flame at the end of it so that the gas gets burned. There's different engineering approaches to it. Some of them utilize a blower to accelerate the gas through there. It gets you a higher efficiency rate. You strategically locate the flare also. First of all, you want it to be at least 100 to 150 feet away from any combustion source. So your oil tanks, the wellhead, you're also going to strategically place it away from roads and buildings, stuff like that. And then we also look at prevailing wind. Naturally you're having gas come out of there. Not 100% of it is getting burnt, just 98%. So ideally we look at where the headwinds are coming from so that there's nothing immediately downwind from it. Just in case we ever have a malfunction or anything like that, it's just better to be prepared and not put anybody in harm's way. There's more considerations than that, but those are the big things that the industry utilizes to flare safely.
That's interesting. Thanks for sharing that. So, we keep using the term methane and, so when you come to methane emissions, so what are emissions and why are they occurring?
Yeah, so essentially when you release any non-combusted gas directly to the atmosphere, That's the blanket term that people are referring to as emissions.
Mm-hmm.
There's a number of causes. You can have the aggregate sum of a lot of very low volume leaks, just a little bit here, like, with, as you can imagine, with a facility, we have lots of piping. And if at a piping connection, if there's just a very small leak, that one by itself may not add up to much. But if you have 100 of them across the facility, the sum of that can, it can start to add up. Unlit flares is another one. Tank venting, just through the expansion and contraction, during the day, especially down here in Texas in the summer, it might be 105 degrees. And then it's a desert climate, so at night it may drop to 65. So you can imagine those tanks breathe. The gases expand, and when they expand, we have hatches on the top called thief hatches. If those aren't designed properly, if those aren't maintained properly, and if the pressure isn't controlled properly, those things act as a safety, a pressure relief valve, essentially. So there could be some venting there if it's not engineered properly. And then combustion engines are used across the field. Compressors, pumps, all that stuff, anything that has a combustion engine, just like your vehicle, that's also a big source of emissions that we track and watch very closely.
All right, that's interesting as well. So, when you talk about emissions, and are there certain industries, or one industry more so than the other, it is more of a culprit or more commonly associated with the increased methane emissions?
Yeah, if from a public perspective, I think everybody naturally looks at the fossil fuel industry, and that's justifiable because through our processes, through the upstream, the midstream transportation, and the downstream, which would be refining and turning the hydrocarbons into a usable product, there are emissions associated with that. It's certainly not the only industry, though. The agriculture industry is a big contributor to emissions, and then waste disposal. There's a lot of you see a lot in the waste disposal industry as well. It just so happens that the fossil fuel industry is under the microscope currently. And the good side of that, though, is with public scrutiny, it's there's more transparency, and it gives more motivation for operators like the one I work for and many others to take a proactive approach and utilize the skill sets we have and figure out a way to tackle this problem.
No, I agree. With the, with technology changing every day, there's got to be better processes in place, today that they were yesterday. So it'll continue to improve. So are there any like incentives that maybe at the state level or a federal level that might incentivize companies or industries to reduce the emissions?
Yeah, I suppose on the soft side, there's sort of a social license to play. Um, I work for a publicly traded company. A lot of people in the oil and gas industry, are publicly traded entities. It's a very capital intensive industry. So you find a lot of publicly traded companies. The investor pool in general, a lot of people are looking at what's called ESG, environmental, social, and governance metrics. People use that as a litmus test to see how sustainable a particular company is. If they see that you're, forward thinking, you're trying to be responsible, you're taking the right steps, you're making the right investments. And then on the SG part of ESG, they also want to see how you're treating your people. How are you governing your company? Are you trying to be fair? Are you giving people equal opportunity? All that type of stuff. So all that gets lumped together, and there's a big impact on the investment side. As far as honestly, though, with flaring and emissions, those are sellable products. So there's also a financial incentive. If you can figure out economic ways to capture those gases, you can sell them. So naturally, venting them, or is the worst case scenario, and then flaring would be the next worst case scenario. With either of those, you don't get any revenue off that gas stream. So there is a financial incentive also to try to figure these problems out so that we can be as efficient as possible and sell as much of the gas as possible.
That's some good information. And usually, if something does have a financial side to it or financial impact, more people are, apt to find ways to increase their, financial gains.
Yep.
So how difficult is it to determine the extent or rate of these emissions?
Yeah, that one can be tricky. It's difficult. It's certainly not impossible. A common measurement for gas is we just use an orifice meter. So you're just in the middle of a pipe, you have an orifice plate, which is just a constriction there. I guess if you think back to the fluid mechanics days for engineers, you're measuring the pressure upstream, the pressure downstream, and that can help you determine your flow rate. The issue with a lot of emissions related stuff is instead of being one large source, although there is a couple larger sources that you'll find, there's a lot of small sources where the flow is so low that you can hardly measure it. In those cases, we're using different technologies to give a best estimate. Infrared technology is one of them. You can do some Google searches and quickly find videos where you can look at a storage tank, for example, and with IR technology, you can see emissions coming out of a tank if it is venting. We can also watch pressure trends, even though they're relatively small. How much gas is going into a system, how much is coming out the other end. And if you have pressure losses other than your friction there in the middle, you can do some calculations and you can estimate low volume leaks throughout there as well.
Oh, pretty cool.
So a little bit difficult. Again, it's something that the process keeps refining and improving. And I think the industry as a whole has some pretty good techniques to quantify those numbers.
That sounds good. That makes sense. So, we covered a couple of deep topics, important topics that we kind of were able to touch base on and maybe bring it to a level where everyone can kind of get a picture of what's going on. So I always try to have a little bit of fun with the guests on the podcast. And, being from Ohio, we have some things in common. We're fellow Buckeye fans. But so let's talk about if you go and be your high school, invite you back for senior day. And you're sitting in the auditorium and a high school senior walks up to you and says, "Hey, Mr. Long, I got a question for you. I'm thinking about going the engineering way when I get to college, but I'm not quite sure. Is there any advice that you could give me?" And what would you say? What kind of advice would you give to this high school senior?
Ironically, I just had this conversation with a coworker a couple hours ago because she's gone back to Colorado to her alma mater to give a comparable talk. And we were talking. We were talking about this very topic, engineering as a whole, not just petroleum. One of the things that we discussed that I think is very relevant is engineering gives you the opportunity to make a tangible impact on the world. Depending on the discipline, it may be very visible. Like civil engineering is a good example. We all drive over roads and bridges every day. We all sit in a building. And we take for granted here, being in the United States, that the roads will always be safe, the bridges will always be safe. That's not necessarily the case in many parts of the world, though. So you have folks like civils. It's very tangible, very visible. Then you got chemical engineers, electrical engineers, petroleum engineers, where we may be a couple steps removed from the end consumer. But if I was talking to a student, I would encourage them to certainly look at the engineering field as a whole. Also try to, when you're deciding what discipline that you would want to look into, don't just look at it, take it at face value. Look at the actual impact that, a petroleum or a chemical may have, for example. Chemical engineers are a great example. We don't see what they do on a day-to-day basis, but every single thing around us comes out of a chemical manufacturing facility in one way or another. So although it's not as visible, they have an equally important impact on the quality of life. The other thing I'd say about engineering is it gives you options. It's very common to see people trained as an engineer, and they, at one point or another in their career, they retool themselves and they go work in a completely different industry. Maybe it's another industry where they're utilizing their engineering degree directly. But you see engineers, you see them in finance, you see them in all aspects of life. It's a rigorous set of courses to go through. But I think with that, it gives you a bit of a badge of honor, and a lot of potential employers look at it and say, okay, if you're able to successfully complete this, I'm sure you can be up to the task that I'm willing to give you. So again, I didn't know what I wanted to do straight out of high school. Really didn't know what I wanted to do straight out of college either. So having a technical background, maybe not just engineering, but STEM in general, it does open up doors for you, and it keeps you from getting pigeonholed into a into a fairly narrow channel of career opportunities.
No, that's some great advice. And, I agree. I talk to engineers every day. Most of them are either, getting ready to prepare for their FE or their PE. And it amazes me that one of the commonalities about it is that you're right, engineering, there's so many roads you can go down. I mean, even if you're just a civil engineer, there's, you can be transportation or water resource or a structural engineer.
Mhm.
But then when you get out of civil, there's still a billion different ways you can go: petroleum, chemical, control systems. So, I'm imagining, since it's such a broad field, that your day probably isn't the same every day. Like if I were to say, hey, Tony, what's your average day like? What could you share with us?
Yeah, it's actually one of the reasons that I chose this particular field. I won't dwell on my background, but I actually worked at an environmental laboratory for 6 or 7 years prior to entering this field. Didn't even get into the oil and gas industry until I was about 30 years old. And at the time, I was looking to go back to school to be a civil engineer, because in the environmental field, I worked with a lot of those folks. Really liked what they did. But I started doing environmental work for my current employer while I was taking my engineering courses for my second degree there, and saw how dynamic the petroleum or the oil and gas industry in general is. As I mentioned, a chemical plant is stationary and you build it
Mhm.
once and then you maintain it. We build facilities every single month. So, and there's a different challenge with each one of them: geography, topography, all that
Right.
stuff. As a petroleum engineer in particular, I still get to deal with civil engineers,
Mhm.
get to deal with chemicals, mechanical engineers, electrical engineers, because we utilize all these services to make our projects run. So my day could be, some days it's sitting in an office doing some economic analyses and forecasting. There's other days where I'll spend days on end out in the field watching a rig while we're working on a well. So I really enjoy it because it's a great blend of technical engineering
Mhm.
and field operations. Some engineers really like the technical stuff, and that's all they want to do. I'm more of I have a hybrid interest. I really like the opposite side of things. I like to see how things actually get done, aside from the plans that we draft up in the office. So I get a good balance of that, and that's one of the reasons I feel fortunate to be in this industry.
Yeah, sounds like an exciting way to spend your day, but you kind of let the cap off the bottle here. You said you
Okay.
want to talk about your background, but when I was looking over the questions today, I noticed that you were a bio major with the chemistry major, but yet you end up in petroleum.
Yeah. As I mentioned, I had no clue what I wanted to do when I got out of high school, and really didn't know when I got out of undergrad. I knew I liked science. I knew I was good at math. Um, I thought I wanted to do something in the medical field, so I started out, went to a small private school there called Muskingum. It was Muskingum
Oh
College
yeah.
at the time, over near Cambridge, Ohio. Majored in biology, had enough chemistry courses to qualify for the minor in chemistry, so did that as well. Had intentions actually of being a pharmacist. And then after my sophomore year, I went and shadowed a pharmacist to see if I would actually like it. It took about 2 hours to find out that wasn't for me, but I was pretty well committed to a biology degree at that point. Um, so I got out, eventually got into the environmental field a couple years later. Like I said, spent 6 or 7 years on the environmental side, got a lot of technical experience,
Mhm.
but a lot of good exposure again to the civil and the environmental engineers, because we would work on a lot of cleanup projects all across the country.
Mhm.
That's where I really developed an interest and a passion for the engineering side of things. And so in my late 20s, I started taking courses to go back and get a engineering degree. Um, Started, going through the prerequisite courses, your general fluids and
Mhm.
statics and thermodynamics, with the intent of doing civil. And then again, with my current employer, I just had so much exposure in this industry. I realized this is something I really liked, and it would give me an opportunity to kind of bridge several areas of engineering. So changed courses, you know, literally changed courses and changed, course of my direction, and entered a master's program at the University of Utah in petroleum engineering. Finished that in early 17,
Mhm.
and have been, been in Texas ever since then, practicing as a professional petroleum engineer.
Yeah, thanks for sharing. That's an interesting avenue that you traveled.
Yeah,
It's kind
a
of
little bit
cool.
non-typical.
Yeah, for sure. So I got a question though. So, COVID has been with us, what, a little over maybe 2 years. And
Yeah.
it's affected a lot of different aspects of, personal life, professional life. For some people, you know, making the transition from working in an office setting to working remote, I mean, it was an easier, I guess, transition for others. So, you were mentioning earlier that, sometimes you might find yourself on a rig or you might find yourself on a well. How did the COVID hit that? Like, what did you guys do as far as how did you maintain your, I guess, field support?
Yeah. So it affect just like everybody else, it affected us in many ways. Not the least of which was the fact that people stopped traveling, stopped using a lot of the products that we produce, and it led to the probably the worst commodity price crash that we've ever experienced in this industry. So you have that aspect of it. I actually, my wife and I took the kids. It was March of 2020. My wife's a teacher, so we went to San Antonio to go to SeaWorld for spring break. When we left, the office was open, and we knew COVID was something. We didn't know what it was. And when we came back a week later, oil prices had fallen through the floor, and I opened up my computer to an email that I wasn't allowed back in the office. So, uh, you know, we
Wow.
tried to figure out how to do all our stuff at home. She taught full time from home. I did my engineering full time from home with two toddlers running around. So I wouldn't say it was the most efficient process starting out. We eventually figured out how to do it, and everybody was figuring it out. As far as field operations, that particularly was a challenge though, because a lot of our people are transient in nature. A
Hmm.
lot of people work 2 weeks on, 2 weeks off, and they'll come out and support you for 12 hours a day for 2 weeks. A
Oh,
day shift,
wow.
a night shift. Travel restrictions made that very difficult. A lot of states had policies that if somebody crossed state line, they had to be
Hmm.
tested. And a lot of our people were relatively close to the New Mexico border. We have a lot of people
Oh.
from Oklahoma, a lot of people from Louisiana and Arkansas that work down here in Texas in this industry. So it was a challenge for us, and then it's still a challenge today. I think everybody's becoming more used to it,
Right.
but we still implement some protocols. Every company, every vendor has their own set of protocols.
Hmm.
Some people do routine testing when they bring new people in location. In general, though, at this point, there's a lot of just enhanced awareness. Trying to be cognizant that if you're not feeling good, it's okay to stay home. There's no shame in that. It used to be you had to show up regardless of how you felt. Now I
Right.
think people recognize that that's not a safe practice to do. So impacted every aspect of our industry. But it gave us an opportunity to adapt. Uh,
Hmm.
it's been kind of interesting too because we learned that we can function across the Teams or a Zoom meeting.
Hmm.
And I'm sure that'll have a ripple effect throughout all the industries because people are going to realize they don't always have to travel to do
Yeah.
stuff. So
Right.
they don't always have to attend meetings in person. So it'll be interesting to see how this plays out, when we look back 10 years from now. But that's just kind of a summary of some of the impacts for us.
Well, thanks for sharing that. That's interesting. And it's great to see that, you guys were able to adapt both inside, in the field operations as well. So I know we've almost hit our time for the day. A lot of great stuff. I'd love to have you back, Tony, but a couple of fun questions left for you.
Sure.
So being in the state of Texas, I guess it depends on where in Texas you're at, but is there an In-N-Out burger by you?
There is, and I've never ate at one. I think there is.
Oh, uh,
Everybody down here loves Whataburger.
that's what I was gonna say, but I don't know if I can have you back. I'm from LA. In-N-Out's huge. Um,
Yeah, to be honest, I've never ate at either one of them.
you you might be getting kicked out of the state of Texas.
You're supposed to, if you're in Columbus, I think, isn't that where Wendy's started? Aren't you supposed to be a Wendy's fan or
Oh,
something?
I can't stay, or I'm
You don't
not.
like
Yeah,
the,
I'm not.
you don't like the square hamburgers?
Not a big fan of the square burgers.
No, there's
But
a lot of pride down here for some of those local chains. I know recently Whataburger, maybe it's been within the last year, got sold to an out-of-state
oh
uh,
wow,
enterprise, and a lot of people were upset about that. But Whataburger and Dr. Pepper tend to be in the Cowboys. Those
of
tend to be
course.
the things that a lot of people down here fixate on. So I just try to assimilate and blend in as much as possible, and still wear my Ohio State and Cleveland Brown stuff.
Brown, yeah, the Browns. That's a tough one. Tough year for the Browns. Hopefully, maybe they'll get on track next year. So,
Yeah, we'll see.
well, yeah, that's what they say in Cleveland, right? Wait till next year.
Yep, it's been that for a long time. So
Before I sign off with you, Tony, let me ask you, what do you think of the Indians' name change to the Guardians?
You know, as much as I like the Browns, I was always a Reds fan, so it didn't impact me.
Tony, we're striking out together here. 0-2. Reds fan, no In-N-Out burger, but we're still going to have you back, Tony.
Yeah, I'd love to come back. No, I enjoyed it. Glad to be a part of this and enjoyed the conversation. Happy to come up with another topic that I think we'll both find interesting next time, and look forward to it.
All right, sounds good. Well, to everyone out there, have a great day. Tony, again, thanks for coming out, and we'll see you together soon.
All right. Thank you so much.
Tony, take care. Bye.